This session we're gonna discuss about chapter 9. Uh, it's basically creation of basic artificial intelligence and enemy behaviors in Unity, which are essential components for creating engaging and challenging game environments. These elements basically introduce dynamics to the game by providing obstacles, adversaries that players must overcome, uh, which helps the gameplay experience with conflict and consequences and rewards. So this not only deepens the player's engagement and investment in the games, but also adds a layers of complexity and strategy to the gameplay. To facilitate the development of enemy AI within Unity, this topic explores several built-in features, components, and classes that streamline the AI design and implementation process. This approach not only simplifies the creation of intelligent behaviors but also opens doors to further exploration and refinement of AI mechanics, and uh, as developers deepen their understanding of C Sharp and Unity capabilities. So the topics uh, which will be covered in this session is in this chapter is the Unity navigation system. Which so understanding Unity's built-in navigation system is important for creating uh, AI that they can intelligently navigate the game environment. This includes moving towards goals, avoiding obstacles, pursuing or fleeing from the player. Uh, and we will also discuss about uh, static objects in the scene and generate navigation meshes, uh, allowing the navigation system to calculate efficient paths of for AI characters. This is foundational for enabling AI movement and behavior within the game world. And we'll also discuss about navigation agents. So navigation agents are components that are attached to the AI characters to utilize the navigation mesh for pathfinding. So this topic will explain how to implement and configure navigation agents to control AI movement behaviors and procedural programming and logic. So developing AI behavior requires a solid understanding of procedural programming and logic. So this involves creating scripts that dedicate how enemies decide to chase the player, attack, retreat, or perform other actions based on the game states and uh, players' action. So we'll also discuss about more about procedural programming, and we'll also discuss about taking and dealing damage. So implementing systems for AI to take and deal damage is essential for creating engaging combat encounters. So this includes setting up health systems, attack mechanics, and interactions between the player and the enemies. We'll also discuss about adding a loss condition, so to heighten the stakes and introduce consequences to the game. This topic covers how to implement loss condition triggered by the player's defeat at the hands of enemy AI, and yeah, refactoring techniques. So we'll discuss about refactoring techniques. So as the game project grows in complexity, maintaining clean and efficient code becomes increasingly important. So this topic offers insights into refactoring techniques that help streamline the code base, making it easier to read, understand, and expand. So by end of this chapter, you will you will be equipped with you will be equipped you'll have a equipped for example the hero born project with a rudimentary yet functional enemy AI system, making significant milestone in the game development. So this foundation not only enhances the current gameplay experience but also sets the stage for further expansions and refinement in the game mechanics and features. So first is navigation. So navigating within Unity is a kin to plotting a route from point A to point B in the real world, but tailored for 3D virtual environment. So Unity's uh, robust navigation system uh, simplifies the programming of complex movements and interactions, which is akin to human navigation skills acquired through experience. So let's break down the Unity's key navigation components and their functions. First, we have NavMesh. Think of NavMesh as a detailed map outlining all walkable surfaces within your game's level. So it's generated through a process known as baking, which analyzes your level's geometry to create an navigable area represented as a unique asset within your project. And we have NavMeshAgent. This component acts as a character aware of NavMesh layout. It intelligently navigates the environment, automatically avoiding obstacles and other agents to reach its destination effectively. We have NavMesh obstacle to ensure that your NavMesh agents can navigate around both static and dynamic obstacles. You attach the NavMesh obstacle component to the objects that should be considered during pathfinding. So this inclusion ensures that agents are aware of potential uh, impediments and plan their routes accordingly. So for our purposes in enhancing enemy behavior, we'll be concentrating on integrating a nav mesh into our level and configuring the enemy prefab as a nav mesh agent. So this setup will enable the sorry, this setup will enable the enemy to move along a predetermined path, exhibiting the intelligent navigation behavior. So while we focus primarily on the NavMesh and NavMesh agent components in this topic, exploring NavMesh obstacles can add further complexity and realism to your game's levels. So implementing a NavMesh is basically you mark the environment, game object, and its children as navigation static to indicate that they should be considered in the NavMesh. And you can use the navigation window to in Unity to bake the NavMesh, analyzing the level's geometry to define walkable areas. The resulting NavMesh, which will be highlighted in light blue, uh, delineates all areas where NavMesh agents can move, laying the groundwork for autonomous, intelligent movement within your game. So this foundation step is in setting up navigation within your Unity project paves the way for creating dynamic, responsive enemy behaviors that enhance the game's challenge and engagement. Next is enemy navigation. So to implement intelligent enemy navigation within Unity, we integrate components that simplify the creation of complex AI movement patterns. So first step is utilizing the navigation NavMesh agents. So Unity's navigation system allows characters to intelligently navigate the game world. So by adding a NavMesh agent component to an enemy prefab, you enable it to understand and integrate with the environment's navigable areas defined by the NavMesh. So this setup facilitates autonomous pathfinding for the enemy, allowing it to avoid obstacles and navigate the level efficiently. And next step would be creating the patrol routes. So to create a patrol route, you first establish a parent game object. You could name something like sorry, patrol route, which this serves as a container for specific waypoints or locations that enemy will visit. So inside the patrol route, you create child game objects like location 1, location 2, etc. So each position at strategic points within the level. So these locations form a patrol circuit that the enemy will follow. Organizing these waypoints under a single parent game object simplifies this management and reference within the game's code. And next is coding uh, the enemy movement. So with the patrol route defined, the next step involves scripting the enemy's behavior to navigate between the waypoints automatically. So this involves programming the enemy to recognize each waypoint as a destination within its patrol loop. So by combining Unity's NavMesh agent for environment awareness and a structured patrol route using empty game objects, you can create enemies that move with a purpose, enhancing the game's challenge and realism. So this approach to enemy AI development not only streamlines the process but also lays the foundation for more complex behaviors such as chasing the player or avoiding danger. Uh, Next is yeah, enemy patrol behavior. So understanding procedural programming is important for developing dynamic behaviors in games, especially for AI movement. So in Unity, procedural programming enables the creation of systematic behaviors for non-playable characters, NPCs, such as enemy patrol patterns. So let's break down how you can apply this concept to move enemy agents along a set path using the Unity's NavMesh system. So uh, as I mentioned, NavMesh and NavMesh agent. So Unity NavMesh is a tool for pathfinding and navigation of NPCs. It defines the walkable areas of the game environment, allowing the NPCs with uh, NavMesh agent components to navigate the world intelligently, avoiding obstacles and choosing efficient paths to their destinations. Next is setting up the patrol location. So by placing the empty game objects at a strategic locations in the level, you create specific points that the enemy agent can visit. So these points allow known as waypoints or patrol locations, form the path that the enemy will follow. And the next step would be procedural programming for patrol behavior. So the core of moving enemy agents lies in the concept of procedural programming. So this approach involves writing logic that executes operations in sequence, such as iterating over a collection of patrol locations and directing the enemy agent to move to each one in turn. So so first you create a list to hold the patrol locations. So this list will be populated with child objects of the parent game object, which is the patrol route, which contains the location points. You'll use a loop for each. Let me bring up the code. Yeah, this is your enemy behavior script. So you'll use a for or for each loop to iterate over the patrol locations. Uh, sorry. For each location in the list, you instruct the NavMesh agent to move to the location's position. So this can be achieved by setting the agent's destination to the position of the current patrol location being iterated over. Optionally, you can also include a logic to wait at each location for set period or perform specific actions before moving to a next point, which enhances the realism of patrol behavior. So the advantage of we'll discuss more about this, but yeah, the advantages of procedural programming in AI movement is, first is efficiency, so which reduces code redundancy by using loops to handle repetitive tasks such as moving through a series of waypoints. And the other advantage is flexibility. You can easily adjust the patrol route by adding or removing locations from the parent game object without needing to change the code. And the other advantage is scalability. The same procedural logic can be applied to multiple enemies or NPCs with varying patrol routes, which enhances the dynamic nature of the game environment. So by utilizing the procedural programming techniques in conjunction with Unity's NavMesh system, you can create sophisticated enemy behaviors that contribute to the immersion and challenge of your game. Uh, so, so the enemy behavior script basically is responsible for managing the enemy's patrol behavior. So the key components of this script includes let me open the current, actually, never mind. So uh, yeah, the key components of the script will include like transform petrol route, so a public variable that holds the a reference to the parent game object containing all patrol points. Uh, this allows the script to access the container and its child objects, and we'll also have a list transform locations, which is a list that will store the transform components of each patrol point. Lists are chosen for their flexibility and the ease of use in adding or removing elements. Uh, what else? So in the start method, we have a initialize patrol route is called to fill the locations list with the patrol points, and initialize patrol route, which iterates over each child of the patrol route game object. The for each loop is a procedural programming technique that effectively process each patrol point, and each child's transform component representing a patrol point is added to the locations list. This list is will later be used to guide the enemy through the patrol route. What else? Yeah, so basically the transform patrol route, this variable is assigned uh, this variable is assigned the patrol route game object from the Unity editor. It serves as an entry point for accessing all patrol points defined in the scene. As I mentioned, list transform locations is basically it acts as a dynamic container for the patrol points. By using a list, you gain the ability to easily iterate over the patrol points and update the list as needed, which provides flexibility in defining the enemy's patrol path. Uh, for each transform child in patrol route, this loop uh, goes through each child game object of the patrol route parent. The transform child represents the transform component of each patrol point enabling the script to access its position in the world, in the game world. Locations dot add child, which adds the transform of each patrol point to the locations list. So this action populates the list with all the patrol points, which the enemy will later use to navigate the level. So by dragging the patrol route game object to the patrol route field in the Unity inspector, you link the patrol route structure created in the Unity editor with the enemy behavior script. Uh, this allows the script to dynamically reference the patrol points and use them to control the enemy's movement. So this setup combines the Unity navigation capabilities with procedural programming to create a dynamic and adaptable enemy patrol behavior. So the use of transform and less transform alongside Unity's NavMesh agent component enables the creation of complex AI behaviors with minimal manual adjustments, streamlining the game development process and enhancing the gameplay. Next is autonomous enemy patrol. So this segment outlines the process of enabling an enemy character in Unity to autonomously patrol predetermined uh, predetermined locations using Unity's navigation system. So let's break down the process and the code implementation. So first, let's understand the process. So yeah, Unity's AI navigation system, which Unity basically simplifies the AI movement through its navigation system, which includes components like NavMesh for mapping walkable areas, NavMesh agents for moving characters, and NavMesh obstacle for defining obstacles. So and next step would be setting up the patrol points. Again, it's the same process. The setup involves creating a route for the enemy to follow. So this can be done by placing enemy empty game objects at desired patrol locations within the scene, as I mentioned. And yeah, make sure you organize them using the game object for easier management. Uh, Let me open the code. Okay, so the core of patrol logic involves scripting the enemy behavior to move to each point sequentially using the Unity's NavMesh agent component for smooth navigation around the level. Here we added a new line using Unity engine.ai, which enables access to NavMesh agent component, which is crucial for AI navigation. And what else we added? Uh, NavMesh NavMesh agent component, which is stored in the agent variable. So this component is responsible for moving the enemy along the NavMesh, guiding them through the through the level based on the calculated paths. Uh, in the uh, initialize patrol route basically method this method populates a list of transform objects representing the patrol points, as I mentioned before. It's not mentioned, the code is not mentioned here, but yeah, it's from the textbook. So yeah, okay. So move to next patrol location. The enemy's destination is set to the position of the current patrol point. The nav mesh agent takes over from here, moving the enemy towards the destination using the most efficient path calculated based on the nav mesh. And the the patrol route cycle, which is the logic for cycling through the patrol points and moving the enemy sequentially from one point to the next, involves checking when the enemy reaches a patrol point, and then updating the where is it, location index, uh, updating the location index to the next point. This aspect, although not detailed in the in this code, it's crucial for creating a continuous patrol cycle. So this approach explains a basic but efficient method for integrating autonomous enemy movement within a game, laying the groundwork for more complex AI behaviors. The use of Unity's AI navigation system simplifies the process, allowing developers to focus on refining the AI's interaction with the game world and the player. Uh, so mm, so let me open updated script. So here the updated enemy behavior script facilitates the enemy's continuous patrol around the predefined location in the Unity scene. So this behavior is as I mentioned, achieved through the combination of Unity's navigation system and procedural programming concepts. So yeah, let's dive into. Uh, Give me 1 minute. I need to explain in this code. So yeah, as I mentioned, you're using Unity Engine.ai, which includes the namespace, which contains classes necessary for navigation and pathfinding functionalities such as uh, NavMesh agent. Uh, so this as I mentioned, this variable holds the reference to the NavMesh agent component attached to the enemy. The NavMesh agent is responsible for handling automatic navigation and pathfinding around the NavMesh. We also have a public transform patrol route. I think I've explained this. It's a public transform variable that reference an empty game object in the scene, which acts as a container for the patrol locations. Public list transform locations, which I'm gonna just go through all of these lines again. It's a list to store the positions of patrol locations extracted from the patrol route game object. Uh, the private variable, which is it's a integer variable used to keep track of current patrol location the enemy is moving towards. And in the start method, the start method is used to initialize the agent, which by fetching the NavMesh agent component, it then calls the initialize patrol route to fill the locations uh, to fill the locations list with the patrol points, and finally sets the enemy's first destination by invoking the move to next patrol location. uh, and initialize patrol route, which this method iterates over the child objects of the patrol route using the for each loop, as I mentioned before. So each child represents a patrol location, and their transform components are added to the locations list. This approach dynamically adapts to changes in patrol points, ensuring the enemy's patrol route can be easily adjusted from the Unity editor. What else? Now let's go through the update method. So the update method contains the logic to trigger a change in the enemy's destination. So it checks if the enemy is close to its current target. Agent dot remaining distance, it's checking with 0.2. and also ensures no path is being calculated by not equal to. When both conditions are satisfied, move to next patrol location is called to update the enemy's destination, and move to next patrol location sets the enemy's next destination using this line. uh, it then increments the then increments the location index to point to the next location in the list. The use of modulo uh, with locations dot count ensures that the location index cycles back to zero after reaching the last point, creating an infinite parallel loop. So this implementation exemplifies procedural programming by systematically updating the enemy's patrol destination. It uses Unity's NavMesh agent, uh, uh, Unity's NavMesh agent for navigation, coupled with the procedural approach to dynamically manage the patrol route through a list of locations. So by integrating Unity's AI and navigation components with procedural programming techniques, the script efficiently manages the enemy's patrol behavior, enabling it to autonomously navigate through set the set patrol points in a continuous loop. So this foundation paves the way for further enhancements, such as reacting to the player's presence and integrating more complex AI behaviors. So we'll discuss the next topics in the next session. We have topics like seek and destroy, health reduction, bullet collision detection. Yeah, we have a couple of topics we'll discuss in the next session.